So, refraction at a sunrise and a sunset. We know that the sun is visible before the actual sunrise, and we can see after actual sunset. Means here when the sun is before rising, we can see the sun because of atmospheric refraction of light, because of atmospheric refraction of light. Atmospheric refraction of light. Refraction of light. Due to the atmospheric refraction of light, we can see the sun before sunrise and after sunset for some time, for 2 minutes. Means here the what is actually happens means consider this is earth and this is horizon. When the observer is at this position, means if the sun is before the horizon, before the sunrise, then the light rays passing through that atmosphere of the earth. Means actually if you compare with the density of the air with compare with the vacuum, that will be 1.0003 atmosphere. Means the density of the air. But near to the earth surface, near the earth surface, the density of the air will be higher. So due to that one, the refraction will be possible. When the sun rays are passing through that atmosphere, the refraction will be possible, and each and every layer and moves towards the normal, because of light rays passing from the less density medium to the more density medium, means rarer medium to the denser medium. So here it is that sun rays are before sunrise, the sun rays are passing into the atmosphere of the earth. Then refraction will be happening in each layer before the earth, because of density is more at the earth surface atmosphere. So that rays moves towards the normal and it reaches the observer, but observer can see the apparent position of sun here. This is the apparent position of sun. The sun position is in this place, but the observer can see due to the atmospheric reflection the apparent position of the sun is here. When the sun is moving before the sunrise, we can see the before the sunrise, and at the evening time after the sunset, due to the time lag will be difference, the time difference between that will be the 2 minutes. Means for the sunrise for 2 minutes and sunset for the 2 minutes, we can see that option. About this one, we can solve, and total time will taken for 4 minutes only. About this one also we can solve one problem also. Here the earth takes 24 hours to rotate around the sun by itself. Earth takes 24 hours to rotate once about its axis, and how much time does the sun take to shift to 1 degree when viewed from earth? Means when viewed from the earth, how much the time taken to shift 1 degree by the sun whenever we viewed from the earth. So here it is that the time solution is that time taken to 360 degrees. Time taken for 360 degrees of its axis. Axis is 24 hours. 24 hours means 1440 minutes. 1440 minutes. For the sun to shift 1 degree, that is equal to 1440 minutes by 360 degrees. Okay, so here it is that by the calculation 6 6 36 6 4 total 4 minutes will take to shift 1 degree. 4 minutes take for 1 degree. This is about, means here we can see the sun before the sunrise and after the sunset for 2 minutes. So the total time lag will be, the time difference between them is 4 minutes, because of due to the atmospheric refraction of light. Here it is that whenever the sun before the horizon, This is the origin. Before the origin, whenever the sun is there, due to the refraction of the light, sun rays are moving into the earth atmosphere. So due to that, the density of the earth atmosphere will be more than the at a vacuum place if we compare with the vacuum. So here it is that due to the reflection, the rays will move towards the normal and reaches the observer. The apparent position of the sun will be here, but actual position of the sun will be here. So that's why we can see the sun before sunrise and after sunrise, the time lag will difference will be there. 2 minutes will take each one. So here is the total 4 minutes take will be the time difference for that. Then here is the problem we can solve. So after knowing the atmospheric reflection of light means about sunrise and sunset of before we can see it appears before and after the sunset and of sunrise because of due to the reflection of light, refraction of light. So now we are going to discuss about that the drowning child, lifeguard and Snell's law. Means consider a PQRS rectangular shape of here is the rectangular shape of swimming pool is there, that is PQRS, and when the god sat outside the pool at point G, here is the point the lifeguard has set, and some of the child is drowning at the point of C. At the point C, the child is drowning in the pool. Then lifeguard enters with the speed of V1 at point X. Speed of God. Speed of God outside the pool is V1. In the pool is in the pool speed that is also V1, that is equal to V2. Means he enters, God enters at point X on the face side of RS at point X and reaches the child with also same speed. When it is clear that V1 is equal to V2 means the velocity whenever the God reaches to the point X and X to C is also same. When the God enters at point X on the side of SR, then God enters at point X. At point X, then Gx is equal to length of L1 means here is the distance of length is taken as L1, and at the same time XC, the distance XC is equal to L2 means here the distance of X2, L2. So the God can move into the two different directions also to save the child, that is in this direction and also the perpendicular line along the point of X. This is L, M. At point A also he can move, and also at point B also he can move to perpendicular to the boy, the child where he is joining to the pool. Those 2 points also enters because of the God enters at point X, so that's why the distance is Gx is equal to L1, X is equal to L2. Then the time taken to reach the point C by the from G is we know that here is the time, here is the one and another path is L2 means time is equal to distance by its velocity. Here the God moved from with velocity G1 from G to X and X to C will be the velocity is V2. So here it is the time taken T is equal to the first distance is L1 by V1 plus L2 by V2. Here to take minimum time, to become time minimum, the lifeguard should that one of the point where he enters into the pool, he must be satisfied by the Snell's law. So here it is the to make time minimum, God enters at point Snell's law has to satisfy. So here the must where the God is has to enter into the pool, the Snell's law must be entered because of another thing is here when God enters at point X, this will be the angle of incidence, means angle G X M is equal to I, that is the angle of incidence. Next one is when the refraction is possible whenever he enters into the pool, then the LXC angle LXC will be the angle of refraction. This will be the angle of refraction and this will be the angle of incidence. So here it is that whenever the angle GXM is equal to I and angle LXC is equal to angle of refraction, then from that angle also we can find out that where the it must be whenever we are taking the angles, that must be follow the Snell's law. It one we should take the to make time minimum, to take minimum time, then one should follow the must be follow the Snell's law. They can be minimum when they can be minimum when sin I by sin R, that is equal to V1 by V2, means sin angle of incidence sin I is equal to, we know that angle of distance motham we can find out that is velocity V1 and sin R is equal to velocity V2. The V1 by V2 be the ratio of the, so the ratio of the speed of a light in vacuum, speed of a light in a vacuum to speed of a light in a medium, means in a medium. This will be the refractive index of the medium. Here it is that when the two values, means the two speeds and the incident and angles are involved in that, when two values are involved, means two velocities and incident and refracted angle are involved in this, then one should follow the Snell's law to take the minimum time. Means here the whenever the velocities V1 and V2 and angle of incidence and angle of refraction is also involved in this, whenever they both total are involved in this angles and speeds, one should follow the Snell's law to take the minimum time. One should follow to take the minimum time when these both are involved, means even two mediums and two speeds, when two mediums and two speeds involved, the one should follow Snell's law to get the minimum time,